So here's the solutions to the practice questions continued again. Questions 7, 8, and 9. Okay, so we'll start with 7. A dentist tested a new whitener for teeth. She found that in 1,050 tests, it worked 1,015 times. What is the experimental probability then that the whitener works? Okay, so this is pretty straightforward, where you're just going to create your probability as a fraction. If it worked 1,015 times out of the 1,050. So you can actually simplify this fraction if you divide them both by, and this is kind of a, you'd have to do some trial and error to figure this out, but divide by 35, the top and the bottom, you'd end up with 29 over 30. Okay, so that's your simplified form of the fraction. And if we look at that as a decimal, that's 0.96 repeated, or 96.6 repeated percent. So pretty good success rate for that whitener. The experimental probability that the whitener works, 96.6%. And then B, the whitener is used on another 8,500 people. What then, what can we, or how many can we expect to have whiter teeth from that? So I'm actually just going to use the decimal form of my percentage, 0.96 repeated, and I'm going to multiply it by the number of people who are going to be in the next trial. So what is 96% of 8,500? So when you calculate that, you're going to get an answer of 8,216.6. We don't really want 0.6 of anybody, so we're going to round that up, 8,217 people. Okay, so about how many can expect whiter teeth? 8,217 people can expect that. Okay, let's go to question 8. Fari was at bat 211 times and hit 97 times. Eric was at bat 234 times and hit 119 times. Which player has the better batting average? So if we look at, let's start with Fari. He had 97 hits out of the 211 times that he was at bat. Okay, so if we look at that as an average, he ends up with 0.459 or about a 45.9% chance that he's going to hit that ball. And then Eric had 119 hits for the 234 times he was at bat. And if we look at this as an average, 0.508 or a 50.8% batting average. So between those two, who had the better batting average? We would say Eric did. Eric had 50.8% or 0.508 batting average. Okay, and you could look at, I'm just going to put AVG. You could look at the difference between them, which is about a 5% better batting average than Fari. Okay, and lastly, number 9. So a 6-sided dice has the colors blue, yellow, orange, pink, red, and purple on it. A spinner has 4 equal sections on it, yellow, blue, red, and orange. If I roll the dice first and then spin the spinner, what is the probability that I will get a combination that makes the color green using blue or yellow? Okay, and we're actually going to get another piece of paper for this one because it will take up a bit of space. So I'm going to use a tree diagram to show the possible outcomes that I could have. So it says that I roll the dice first, okay, and that has the 6 sides on it of blue, yellow, orange, pink, red, and purple. I'm going to just put the U so I know it's different from the pink. Okay, and then I'm going to spin the spinner, and that has 4 equal sections on it. So 1, 2, 3, 4, 1, 2, 3, 4, and so on and so forth. So I can figure out what all of my possible combinations will be. That spinner has yellow, blue, red, and orange on it. Okay. So we need to find the combinations that will give us the color green, which we know is made up using yellow or blue. So if I get blue on the dice and then I get a yellow on the spinner, that will make the color green. None of the other options there will make the color green. If I get a yellow and a blue, that will make the color green, and none of the other options will. Orange won't make a green with anything, pink won't make green with anything, red won't, and purple won't. So if I look at this, I should have put spinner here, sorry, spinner. If I look at this, how many possible combinations, or what's the probability that I will get a combination that will make green? Right now it's 2 out of, and I have 1, 2, 3, 4, 5, 6 times 4. Okay, that's usually a faster way to figure out your combinations. 6 times 4, right, is 24. You could also just go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 24. Okay, so 2 over 24, and we know simplified that will just be 1 out of 12. So I have a 1 in 12 chance of getting a combination of colors that will make green. I can also write that as a decimal, which will be 0.083 repeated, or 8.3 repeated percent. Okay, so fairly low chance of me actually getting colors that will equal green, but you do have a chance, I guess. So hopefully this helps clear up any questions that you might have had about the answers.